Welcome back, everyone. Today we're diving into one of the weirdest binary star systems in our galaxy. Thanks to new data from NASA's Hubble Space Telescope, the retired Sophia Observatory, and other missions, astronomers have revisited HMSG, a system that burst into the spotlight 40 years ago as a bright and long-lived nova. So, what's a nova? It's a star that suddenly gets super bright and then fades back to normal over a few months or years. But HMSG is different. Back in 1975, it became 250 times brighter and didn't fade away quickly like other novae. Instead, it stayed bright for decades, and recently, it's gotten hotter but oddly dimmed a bit. What makes HMSG special? HMSG is a type of symbiotic star. It has a white dwarf and a giant companion star that produces a lot of dust. These two stars are in a crazy orbit around each other. The white dwarf pulls gas from the giant star, forming a super hot disk around it. Sometimes, this gas gets dense enough to trigger a thermonuclear explosion, causing a spectacular outburst of brightness. In 1975, HMSG went from being an unnoticed star to one that grabbed the attention of astronomers everywhere, said Ravi Sankrit from the Space Telescope Science Institute, SDSCI. Recently, Sankrit and his team used Hubble and Sophia to see what's changed with HMSG over the last 30 years, from infrared to ultraviolet light. New discoveries. In 2021, Hubble's ultraviolet data revealed a strong emission line of highly ionized magnesium that wasn't there in 1990. This indicates that the white dwarf and its accretion disk have gotten hotter, with temperatures soaring from under 400,000 degrees Fahrenheit in 1989 to over 450,000 degrees Fahrenheit now. This magnesium line is just one of many in the UV spectrum that can help us understand the system's energy dynamics over the past 3 decades. When I first saw the new data, Sankrit said, I was like, wow, this is what Hubble UV spectroscopy can do. It's spectacular, really spectacular. Using Sophia, which retired in 2022, the team detected water, gas, and dust moving around the system. The infrared data shows that the giant star, which produces a lot of dust, returned to its normal behavior shortly after the explosion but has dimmed in recent years. A new puzzle to solve. Monitoring the mystery. With Sophia, they saw water moving at about 18 miles per second, likely the speed of the hot accretion disk around the white dwarf. The gas bridge between the giant star and the white dwarf is now about 2 billion miles long. The team is also working with the American Association of Variable Star Observers, AVSO, and amateur astronomers worldwide to keep an eye on HMSG. Their ongoing observations are uncovering changes not seen since its explosive event 40 years ago. Symbiotic stars like HMSG are rare in our galaxy, and seeing a nova-like explosion is even rarer. This unique event is a treasure for astrophysicists, spanning decades, said Stephen Goldman from SDSCI. So, there you have it. HMSG continues to fascinate astronomers with its unusual behavior and long-lasting brightness. Make sure to like, subscribe, and hit the bell for more exciting space news. See you in the next video, and keep looking up.